So this is the sixth question in second bit. Okay, we have to draw the free body diagram of all the forces acting on this body. Okay, this body is placed on the inclined plane. Okay, this is a wedge. Here we have the angle. Okay, so what are the forces acting on a body? See, one is gravitational force acting on this body. This gravitational force act downward direction. W is equal to mg. So this body in contact with this wedge, this is the surface, right? Perpendicular to the surface, which force acts? Normal force. Okay, so if this body accelerates down, there is a friction act between this body. Okay, when this body is coming this way, friction opposes the direction, right? Opposes the relative motion. So when body is sliding this way, friction direction is opposite. Here friction coming to act between the two surfaces. This is a friction direction. Okay, but here you have to understand this normal force should be balanced by opposite one force, right? Whenever one force act this way, okay, compulsory opposite another force should act this way, right? Here also frictional force is this is. When one force act this way, then another force also should balance this force this way. Okay, yes sir. Okay, then what are the forces acting? Now we are going to discuss. Here this is weight, right? Okay, w is equal to mg. If we extend this continuously, it also makes 90 degrees. Here what is the angle here? 90 degrees. This is theta, this is 90. Then what will be the angle here? Let's say x. We don't know that angle. So what is the total angle present in the triangle? 180 degrees. X plus 90 degrees, x plus 90 degrees plus this angle, all together 180 degrees. The total sum of the three angles in the triangle is equal to 180 degrees. Now we have to calculate this x. Okay, then you have to bring this 90 plus theta from LHS to RHS. So x is equal to 180 degrees minus 90 plus theta. Okay, then x is equal to 180 degrees minus into 90 minus 90 minus into plus minus theta. X is equal to 180 degrees minus 90 minus theta. So this angle will be 90 degrees minus theta. Okay, so if you extend the same thing, here what will be the angle? Here 90 degrees, so here also it should be 90 degrees. And what is the thing we have discussed here? Same thing also applicable here also, no? Same, this diagram and this diagram almost the same. So what will be the angle here? This angle will be same, 90 degrees minus theta. Okay, of course I am not using mathematical terms in depth. Okay, right. Now see, this is a gravitational force which is acting downward direction this way. Okay, I am going to divide this into two components. Okay, this way. This is one component, this is called horizontal component, and this is called vertical component. So this is called resolution of the vectors. Okay, so here also we get to w is equal to mg, here also we get to w is equal to mg. Okay, okay, this is mg, right? W is equal to mg. Here also we get to w is equal to mg. But here when this is 90 minus theta, when this total, this is 90 degrees minus 90 minus theta, 90 degrees minus 90 minus theta. Okay, so 90 degrees minus into 90 minus 90 minus into minus plus theta, 90 minus 90 theta. So 90 degrees minus 90 minus theta is equal to theta. So here this angle we get is theta. Okay, see, this angle we get theta from this concept, because this is 90 degrees, this is 90 minus theta, then we subtract this particular angle from total 90 degrees. Here this angle we get how much, Nana? Theta. Okay, so according to vectors concept, theta is towards here, so it is a cos theta. Okay, opposite side can be taken as the sin theta. Okay, the theta, the side which is adjacent to the theta can be taken cos theta, and opposite to another side which is not adjacent to the theta, that is taken as the sin theta. So why sin theta cos theta should be taken? It is actually vectors concept. Okay, if it is possible, I will introduce the vectors concept in future. So this is called resolution of vectors. There you will understand Here we have to understand only one important thing, as you are 8th class academics, basic knowledge is required. This normal force is balanced by this mg cos theta. This frictional force is balanced by the mg sin theta. So this gravitational force actually divided into two components. Okay, if it is required, I will upload another video related to this, how to take here cos theta and why to take here sin theta. I will related to this, I will upload one video for understanding small basics, because these basics are very important. Many of the students, they don't know how to take sin theta and cos theta. That is why I will try to upload one more video related to this. Okay, meanwhile you just write down, because we have to draw the free body diagram. So question should be finished. This is the answer. Okay, but why here theta will be taken, how theta we get, we understood, but why cos theta sin theta taken, you did not understand. I know that, because everything you understood except this one. Okay, students, those who are watching that intermediate students can understand all these things, because resolution of vectors comes in the intermediate second chapter. Okay, but you are 8th class student. Even though I will try to upload one video related to this. Okay, please note down this. So higher order thinking questions, this is the third bit, higher order thinking questions. In this, if you push a heavy box which is at rest, you must exert some force to start its motion. However, once the box is sliding, you apply a lesser force to maintain the motion, because initially when box is rest, whenever you try to apply the force, right, this box unable to move, because there is one friction acting between. That friction is called static friction. Due to the static friction, initially this box is we are unable to move the box, but the static friction increases whenever our applied force increases. At one point of time, our applied force increases the static friction. Static friction has a limit, so the maximum limit of static friction is called limiting friction. Then what happens? Then object starts sliding. Once the object starts sliding, okay, once the object starts sliding, we need not to apply that much force, because when object is moving, another friction is coming to play. What is that? Sliding friction. Okay, sliding friction is less than static friction. Okay, so these types of frictions actually we haven't discussed in this chapter. Okay, we discuss these types of friction in the next chapter. I discuss this question again after the friction chapter finished, because with the help of activities, we understand what is static friction and sliding friction. When we do some activities, you will understand static friction, sliding friction. Once you understand that, you will understand this question easily. Okay? That is why you don't worry about this question. In the second chapter, this question again after completion of the videos on static friction and sliding friction. Okay? So don't worry about that one. Second, how do you increase the pressure by keeping the area unchanged? Already we have discussed in the just before video. So the relation between the pressure and force is pressure is equal to force by area. When area is unchanged, pressure is directly proportional to force. If the force increases, pressure also increases. When force is unchanged, pressure is equal to force by area. When force is constant, area is indirectly proportional to pressure. When area decreases, pressure increases. When area increases, pressure decreases. When area decreases, pressure also increases. This concept, okay, we have discussed with more examples in the previous video. Already who are watching videos part by part, you are able to answer these questions very easily. Okay, so this is only revision part and just recapitulation part. Okay, this is the discussion of only question answers. The detailed explanation already has been done. Okay, we are recalling all those key concepts and main concepts. Okay, right. So imagine that friction disappeared from the earth. What will happen? Already we have discussed in the previous question. Friction facilitating many activities, to walk, to run. Okay, when the driver apply the brakes, the vehicle come to rest because of friction between the tires of the road and road, right? Tires of the vehicle and road, right? Now, if that friction disappear, what happen if the driver brakes? Do that vehicle come to rest? No. Can we walk? No. We skid. Can we lift the bag? No. Can we write with the marker? No. Can you write with the pen? No. Can you lift the bottle and drink the water? No. All these things are not possible. Okay, so you can write these examples in your own manner. Okay, right. Okay, so with this video, our lesson first chapter is successfully finished. Students, actually nowadays there are many digital boards, okay, simply by click, okay, by scrolling up and down they are explaining, okay. Even though why we are discussing this way, because in those particular videos, okay, properly there is no order how students should understand the basics. So basics are not explained clearly. So our motto is we are explaining the basical concepts, okay. Only for basics you have to listen these videos, okay. These videos help you to learn the important basics. See, without foundation a building never stand. So this is good important basics, okay. You know how electric bulb works. That electric bulb, how it works, we discuss in the academics, okay. How that electric energy converted into heat energy, all those things we will discuss in the foundation side, okay, with formulas. So those things you will understand when you understand the basic concepts. You are able to get the MSET rank, NEET rank, all those things. Whenever you understand what is friction, what is static friction, what is sliding friction, you can do the problems, okay. So without knowing the friction, can you do the problems? Without knowing the concept, can you solve the problems? So that goes actually learning by heart method. So that is why we are introducing only basics, okay. Then in future also we will upload some important courses also related to that, how to solve the problems in physics if it is possible. So meanwhile, please try to listen these videos and support our channel, okay. So thank you children, have a nice day. Now some basic numericals we discuss related to the pressure, which is present in the first chapter force in physical science class 8, okay. So here surface area of an object is given 20 meters square. So area is equal to 20 meters square and a force of 10 newtons. So what is the force acting on that area? 10 newtons, okay. Then we have to calculate the pressure. So area is given, force is given, and asking to calculate the pressure. So pressure is equal to force by area. This is our formula to calculate the pressure. Then pressure is equal to, what is the force value? 10 newtons by what is the area value? 20 meters square. So 10 ones, 10 twos, it is 1 by 2 or 0.5, okay. Newton meter square, Newton per meter square, or it is also called Pascal. We will discuss the second one, okay. I will give you few minutes of time to solve the second problem. Will you try? Please try. I hope you tried, okay. Now you understand what is given. Force is given, how much? 50 Newton. What is given? Another one, area is given. So force is given 50 newtons, area is given 10 meters square. Then we have to calculate the pressure, okay. What is our formula? We have to calculate the pressure. Pressure is equal to force by area. So pressure is equal to, what is the force value? 50 newtons, area value 10 meters square, right. So 10 ones, 10 fives, then pressure is equal to 5 Newton per meter square or Pascal, okay. Coming to here, there is a brick. This is a brick. This brick has length 30 centimeters. This is length, this is breadth, and this is height, okay. So it is cuboid in shape. So it has a length, breadth, height. This weighs 24 newtons. So what is the weight of this brick? 24 newton. Weight is nothing but force. Weight is due to gravitational force, okay. So it weighs 24 newtons. W is equal to mg. So force is given 24 newtons on the ground. Find the pressure exerted. Again we have to calculate the pressure. So pressure is equal to force by area. Force value is given 24 newtons, okay. Newton refer unit of the force, okay. If only mass is given, okay, they will be given in kgs, okay. Then we have to convert into newtons by using W is equal to mg formula, but already they have given the newtons, so it can be considered as force only, right. Then we have to calculate the pressure, but area is what? What is the area? Area formula, length into breadth, okay. So area is equal to length into breadth. Length how much? 30 centimeter. Breadth how much? 10 centimeter. This is length and this is breadth, okay. 30 into 10, 300. Centimeter into centimeter, centimeter square. Okay, but here Newton is the SI unit, centimeter square is the CGS unit. We can't solve this problem this way. We have to convert this centimeter square into meter square. What is the relation between the meter square and centimeter square? So 1 meter square is equal to, can be written as 1 meter into 1 meter. Now we are understanding the relation between meter and centimeter. So we have to convert these meters into centimeter. 1 meter is equal to 100 centimeter. So 100 centimeter into 100 centimeter. 100 into 100, 10,000 centimeter square. So 1 meter square is equal to 10,000 centimeter square. Okay. Then 1 centimeter square is equal to how much? This 10,000 which is multiplying. If you transpose from RHS to LHS, divides 1. So 1 by 10,000 meter square. So in the place of this centimeter square, we have to write this value 1 by 10,000 meter square. Hence we know that 1 centimeter square is equal to 10,000, 1 by 10,000 meter square. That value we have to write in the place of centimeter square. If you write, okay, 300 is as it is. In the place of centimeter square, we have to write 1 by 10,000. 1 by 10,000. Okay. So 300 by 10,000. 2 zeros cancel. That is 3 by 100. Okay. So 3 by 100 is nothing but 0.33. 0.03, sorry. 0.03 meter square. What is this? Area. Okay. So now pressure is equal to, what is the force value? 24. What is the area value? 0.03. Okay. So if you remove the decimal, here 2 digits we have, so 2 zeros can be kept. That means 24 can be multiplied by the 100. 24 into 100 by 3. 3 ones, 3 8s, 24. 8 into 100. 800 Newton per meter square. This is the answer. Okay, so these are some basic numericals which we have, okay, in this chapter. Actually we have only one numerical, this is, but some extra numerical also I gave you for practicing exams. Okay, so thank you children. Please note down all these numericals in your notebook and refer those.